Hello everyone, I am Divyaraj. My topic for term paper is parallel processing in data mining. So I'll be covering what data mining is, different data mining techniques, the challenges of data minings, and I'll be covering few techniques, the parallel version of few techniques of data mining. To begin with, let's see what data mining is. Data mining is a process that involves extracting useful and actionable insights and patterns from large data sets. It uses techniques and methods from machine learning, statistics, and database systems. The goal of data mining is to discover hidden relationships and patterns in data and use that knowledge to make informed decisions. To give you an example, let's say there is a florist who wants to figure out how many flowers he should get, or what type of flowers he should get for his next event. So through data mining, the florist can assess past sales, check what customers are searching for online, gauge their interests through social media posts, and make projections based on the success of other recent events during that year. And so basically asking the right questions and collecting the right data to answer those questions is critical to successful data mining. Now let's take a look at where data mining is used. So it is used in market and financial analysis. So a lot of different organizations, including the banking sector, make use of data mining to have better understanding of market risks. So it finds its utility in credit ratings and intelligent anti-fraud systems, which are responsible for analyzing car transactions, purchasing patterns, and many other financial data relating to the customer. They're also used in education when it comes to educational data mining. So it helps schools and universities track students' academic progress and allows them to do better after analyzing their performance. It's also used in fraud detection. So when it comes to fraud detection, analytics relies on machine learning to reveal patterns and send the information to algorithms, which in turn basically makes the process of detection easy and prevents the happening of fraudulent behavior in the future. Apart from that, we have lie detection, then CRM, manufacturing engineering, among various other use cases. Now let's take a look at various different data mining techniques. So we have classification. So classification involves grouping data points into predefined categories or classes based on their attributes. So basically, this technique is commonly used for tasks such as customer segmentation and fraud detection. Then, sorry. Okay. And then we have regression. Regression involves modeling the relationship between variables in a data set to make predictions about future outcomes. It is used in sales forecasting and risk analysis. Uh, Apart from that, we have clustering. Clustering basically involves grouping similar data based on their attributes, and it is used in market segmentation and anomaly detection. Then we have anomaly rule mining, association rule mining. So association rule mining basically involves identifying patterns in data where certain events or items are associated with each other. So it is used in recommendation systems. Then we have neural networks, decision trees. So like decision trees are like type of machine learning model that involves creating a tree-like structure to model the relationship between variables in a data set. So they are commonly used in predictive analysis and risk analysis. Okay, so now moving on to the challenges faced in data mining? So there are various challenges that are faced in data mining, which we could solve using parallel processing. One of the biggest challenges in data mining is scalability, particularly when processing large data sets. Traditional data mining algorithms can be computationally intensive and may not be able to process large data sets in a reasonable amount of time. So parallel processing can help solve this challenge by distributing the computational workload across multiple processors or machines. And by breaking down data mining algorithms into smaller independent pieces, which could be executed simultaneously, the, the parallel processing can improve the performance of the algorithms. And again, parallel processing, they utilize resources more efficiently and effectively, um, because they utilize all available processors or machines, and which in turn reduces the cost. So in general, I mean, data mining algorithms are computationally expensive, and um, uh, also the cost is high. So parallel processing is something that could help reduce the cost. So moving on to parallel processing, we already know what parallel processing is. So we just want to divide a task into small tasks that can be processed simultaneously, and can be run on multiple processors or machines. So we want to see how we can use parallel processing in data mining, to reduce the speed and the efficiency, and improve the efficiency. So the first data mining technique that we're gonna see is clustering. Clustering is a technique used in data mining and machine learning to group similar data points together based on their characteristics. The goal is to identify meaningful patterns and relationships between the data, and to group data points that share common attributes into separate clusters. So it can be used in like various range of applications, like image processing, market segmentation, and anomaly detection. So we will be parallelizing uh, this particular clustering method, which is called K-means clustering method. So like before moving on to the parallelized version of it, let's just quickly see how the normal mechanism of K-means clustering works. So basically it works by dividing a data set into specified number of clusters, with each cluster being represented by its centroid or its mean, and the algorithm then assigns each data point to the cluster with the closest centroid, and then updates the centroid of each cluster based on the newly assigned data points. So then this process is basically repeated iteratively until the centroids no longer change, or predefined stopping criterion is met. Now let's take a look at the parallel version of it. So basically, the clustering algorithm requires massive computation because we are calculating distance between each data point and each centroid for every iteration. Since the calculation of appropriate centroid for each data point is independent of others, um, so we can parallelize it. So we can parallelize by dividing the dataset into smaller subsets and running the k-means algorithm on each subset in parallel. And then the results from each subset can then be combined to generate the final clustering model. Now let's move on to another data mining technique that we're going to see, which is classification. Classification is a technique used in machine learning and data mining to categorize data into one of several predefined classes or categories. So basically, the goal is to learn a function that maps input features to class labels based on the training data set with labeled examples. So the resulting function can then be used to predict class label of new and unseen data points. Okay, so it is used in wide range of applications like spam filtering, image recognition, and sentimental analysis. The version that we're going to parallelize uses gradient descent. So let's just quickly see what gradient descent is. So gradient descent is basically an algorithm used to minimize a very common class of loss functions. So we start from a random estimate of solution, and we make several iterations or passes over data. And in each pass, we update the current estimate of the solution by taking a finite step along the gradient, which is basically the slope of the function. And then we repeat this process until we reach the minimum, which is basically the bottom of the function. And so this was gradient descent. Now let's compare it with stochastic gradient descent. So like one of the main disadvantages of gradient descent is that it requires many iterations like before reaching a reasonably good solution. So I mean, there are modifications that have been done on gradient descent, like BFGS and accelerated gradient methods, but this still requires several passes before they can get to a good solution. So what we can do is we can use stochastic gradient descent. So instead of using the whole data, what we do is we draw a random example from the training data and perform a gradient descent like update with respect to the single example. So unlike many algorithms, I mean, it doesn't actually need all of the data to be in your memory. So the algorithm only requires a single training data point to be in the memory. And also like it reaches to a good solution very quickly, but can take forever to get to the best solution. But I mean, this turns out not to be a problem in machine learning because getting the best solution could in fact result in overfitting. So now let's look at the parallel version of stochastic gradient descent. So in parallel version of stochastic gradient descent, we have two different type of computers. One is the parameter server and another is worker node. So the parameter server is where the deep learning model is defined, where the aggregation from worker nodes occurs and is responsible for communicating the deep learning model and training data to the worker nodes. And the worker nodes are responsible for training the model on the training data, communicating the changes to the model back to the parameter server, and perform the bulk of the computations throughout the training process. So the entire training data is divided into n parts, where n is the number of worker nodes in the cluster, and each part is sent to only one worker node. So a single neural network model is then defined and copied to each of these nodes, and each worker node has a subset of training data, and each has an identical copy of the model. So then each of the worker nodes trains its model on its subset of the training data, and um, once all the workers are done with the training process, all nodes transmit to the parameter server the new model they just trained. So I mean, since training a neural network model only modifies the weights between the nodes, so it is only the weight changes that are sent back to the parameter server. So specifically, like each node's weight updates are divided by the number of nodes, since the weights are aggregated only after all the nodes are processed. All the nodes have processed their subset of the training data, and then the result is basically a new neural network, which is then again redistributed to each worker nodes, and then the process is repeated. So an important thing to note here is the aggregation and the redistribution of model is how the implementation utilizes multiple computers to train a single neural network. in a coordinated way, as well as how this implementation is a synchronous one. Now let's take a look at the algorithm for it. So this is the like basic algorithm of stochastic gradient descent. Like in the parallel, what we are doing is basically we are dividing the training set into n parts, and then we are basically sort of giving each part to each node, and then we are like aggregating the results from each node, and then again we are performing the iteration for t number of times. Moving on, another data mining technique that we're going to discuss is association rule mining. So association rule mining basically it's a data mining technique that involves discovering interesting relationships or rules between variables in large data sets. So it is commonly used for tasks such as market basket analysis, where the goal is to identify patterns in customer purchasing behavior. And so this mining technique works by analyzing frequency of co-occurrence of items in a data set, and then generating rules that specify the relationship between them. But then these rules can then be used to make recommendations or predictions about future behavior. So association rule mining is particularly useful for identifying unexpected relationships and patterns that may not be immediately apparent to the human eye. So let's look at the parallel versions of association rule mining. So there are two algorithms which are mainly used when dealing with association rule mining. The first one is a priori. So it is an algorithm used in association rule mining to identify frequent item sets in a data set. So how they parallelize it is basically the data set is partitioned into like various portions and then distributed across multiple processors or machines. And then the frequent item sets are computed in parallel. So basically, this can greatly improve the performance of association rule mining on large data sets as they handle the computational workload more efficiently than a single processor or machine. Another is FP growth algorithm. So basically, it's a frequent pattern mining algorithm used in data mining and machine learning. So it works by constructing a compact data structure called the FP tree to represent the frequent patterns in a data set, and then recursively mining the tree to identify frequent item sets. So the FP growth algorithm is often faster and more memory efficient than other frequent pattern mining algorithms, so which makes it a popular choice. So the parallelized version also works the similar way as the a priori version, a priori algorithm. So we basically divide the data set into multiple partitions and feed into different machines, and then basically collect the data after the computation is done by each processor or machine. Now let's move on to the conclusion. So parallel processing accelerates data mining. So distributing the workload across multiple processors or machines allows data mining algorithms to process larger data sets more quickly and efficiently. Also, it improves the performance. It breaks down the computational load, and the training is done quicker, and it is done in an effective manner, which can improve the accuracy of resulting models. Also, the scalability and speed benefits are there. It can handle large data sets, more complex algorithms, and reduces the time required to train models, and enabling organizations to extract insights more quickly. But still, there are some challenges that remain, like data quality and privacy challenges. So distributing data across multiple processors can make it difficult to ensure quality and consistency. and raises privacy concerns that must be addressed. But like overall, parallel processing is valuable for data mining. It is a tool that can that enables organizations to extract meaningful insights and patterns from the data in a timely and a cost effective manner, gaining a competitive edge and making more informed decisions uh, about their businesses. Thank you.